Hello students, today we will start with our NEET PYQ series and we are starting with the first chapter of class 11 chemistry, that is some basic concepts of chemistry. So let's start. The question is 1 cc of N2O at NTP contains, different options are given. The first option is regarding the number of atoms, the second option regarding the number of molecules, the third option is regarding the number of electrons, or whether uh, it's all of the above. So let's see. Now see which point is given. The point is 1 cc of N2O, right? So volume of N2O is 1 cc. Now we all know that the volume of 1 mole of any gas at NTP is 22400 cc, right? So here number of moles is equal to 1 upon 22400. So we have got the number of moles. Number of moles of what? Number of moles of N2O, right? Now from here we can easily calculate the number of molecules. So let's calculate the number of molecules. Now you know that 1 mole contains how many molecules? Avogadro number. So if 1 mole contains Avogadro number of molecules, then 1 upon 22400, that will contain how many molecules? So it will be multiplied by Avogadro number, that is 6.02 into 10 to the power 23. So the answer is 6.02 into 10 to the power 23 divided by 22400. Okay, so that actually goes with option B. So option B is a correct answer. Now let us look at the other options as well. Now option A is regarding the number of atoms. Now you can see that in N2O, that is nitrous oxide, the number of atoms in one molecule is 3, because there are 2 nitrogen atoms and 1 oxygen atom. So let's see the number of atoms. So the number of atoms will be number of molecules, that is 6.02 into 10 to the power 23 divided by 22400 multiplied by 3, because each molecule contains 3 atoms. So the total number of atoms will be the total number of molecules multiplied by 3. Now let's assume 6.02 to be just 6. 6.02 to be just 6. So here the answer will be 18 into 10 to the power 23 divided by 22400, right? So if it's this, now let us look at the option A, 1.8 into 10 to the power 22 divided by 224. So it's actually 1.8 into 10 to the power 24 divided by 22400, right? So it's coming to be 1.8 into 10 to the power 22 divided by 224. So this is also a correct figure. The option A, 1.8 into 10 to the power 22 by 224, 1.8 10 to the power 22 by 224 number of atoms. So option A is also correct. So if two options are correct, that means all of the above will be the answer. Okay, but still let's see option C. Option C is regarding number of electrons. Now let us look at the molecule of N2O. Now in N2O, number of electrons in each molecule is equal to what? See, nitrogen's atomic number is 7, so 7 multiplied by 2 plus atomic number of oxygen is 8, that is 22 electrons, right, in each molecule. Therefore total number of electrons is equal to 22 multiplied by the number of molecules. Number of molecules is 6. We can assume 6.02 to be 6. So 6 into 10 to the power 23 divided by 2 to 4, right? 6 into 10 to the power 23 by 2 to 4, 400, sorry, 2 to 400. So it's like 132 into 10 to the power yeah, we can write is to be 20, 10 to the power 21 divided by 2 to 4, right? So let's see option C, 1.32 into 10 to the power 23 by 2 to 4. So yes, it's 1.32 into 10 to the power 23 divided by 2 to 4. So this is option C. Option C is also correct, which means ultimately it's option D that is correct. Okay, so in this question option D is the correct answer. That means all of the above. So in this question you can see option D is the correct answer, that is all of the above. Okay, so I hope you have understood this question. So let us move on to the second question. The second question is from 1989 exam. The number of oxygen atoms in 4.4 gram of CO2 is what? So number of oxygen atoms we have to find uh, in 4.4 gram of CO2, right? So let's see the molecular weight. The molecular weight, the molecular weight of CO2. The molecular weight of CO2 is equal to carbon's atomic weight is 12 plus oxygen's atomic weight is 16 multiplied by 2, that is 44. So number of moles of CO2 is mass divided by molecular weight, that is 4.4 divided by 44, that is 0.1. So we have got the number of moles. Now the number of CO2 molecules is equal to what? It will be number of moles multiplied by Avogadro number, that is 6.02, or we can assume it to be 6. Just a minute. Just 6 into 10 to the power 23. That is, this is the number of molecules. Now we have to find the number of atoms, oxygen atoms. Now in each CO2 molecule, you know that 2 oxygen atoms are present. So oxygen atoms number of oxygen atoms is equal to twice the number of CO2 molecules. That is, this is the answer, and let us calculate the number. It is coming out to be 2 into zero point 0.1 means 0.2 into 6 means 1.2 into 10 to the power 23. So 1.2 into 10 to the power 23. So this is the number of oxygen atoms present in the given amount of CO2. So option A, yes, it's option A, which is the correct answer of this question, right? So I hope you have understood this question, and now we are moving on to the next question. The question which again a 1989 question. What is the weight? So we have to find out the weight of oxygen required for the complete combustion of 2.8 kg of ethylene. Clear? So what we have to write a reaction here. This is a stoichiometry based question, and we have to write the reaction between ethylene and oxygen. So the reaction between ethylene and oxygen is ethylene, which is a gas, oxygen, which is again a gas. The product is CO2 gas plus H2, that is a liquid. So here it is 2 CO2, 2 H2O, so 2 2 are 4 plus 2 is 6, it's 3 O2. So you can see that 1 mole of ethylene is reacting with 3 moles of oxygen, right? 1 mole of ethylene is reacting with 3 moles of oxygen. So what is the molecular weight of ethylene? Let us look at here the molecular weight of ethylene is carbon is 12, so 12 into 2 plus 4 hydrogens are 4, that is 28, and the molecular weight of oxygen, that we all know, 16 multiplied by 2, that is 32, right? So uh, here we can say that 28 gram of ethylene is reacting with 3 into 32, that is 96 gram of oxygen. So 28 gram of ethylene is combusted by 96 gram of oxygen. So it's very easy, 2.8 kg of ethylene, because that is given in the question. So if 28 gram is combusted by 96 gram of oxygen, then 2.8 kg of ethylene will be combusted by 9.6 kg of oxygen, right? 9.6 kg of oxygen. So it means 9.6 kg of oxygen is required. That is option C. That is option C. Yes, it's option C. That is 9.6 kg of oxygen is required for the combustion of the given amount of ethylene. So I hope you have understood the questions that I have discussed in this video. If you like the video, then like it, share it, subscribe this channel. Okay, thank you.